Hello? Rescue hooks to rescue, Mayday! Get ahead, West. Fast Mayday, what's your location? Get the hell out of here, hurry up! We need radio silence, baby. Water in that 2.5 inch line. 48 inch water in a 2.5 inch line. To the rope, to the rope. 35 in the rear, 35 in the rear.
Welcome to the Emergency Traffic Podcast. Hello and welcome to another episode of the Emergency Traffic Podcast. I'm Paul and I'm joined this week by my co-host Denis. This is where we talk about firefighter line of duty deaths and we learn from these tragic incidents. First of all, we always team... How you doing, Denis? What's new in Nova Scotia?
I'm fine, Paul. How are you, sir?
Pretty good.
It's June in Nova Scotia, which means one day you can fry eggs on the sidewalk, and the next day they're frozen, so you don't have to worry about preserving them. So
sounds like Alberta to me.
Yeah, single-digit nights and double-digit days, as in the 20s. So that's good. I mean, we like a little variety. Makes the black flies happy, so it's all good. My grass is green.
Our grass is dying. It's been so dry here. As you know, everybody's heard about the wildfires and stuff. And we're starting to get a few convective thunderstorms kicking around. So, but we haven't had much rain. Down south, they got a bit of rain, but up north really needs rain. Northern Saskatchewan got rain, so it saved La Ronge and Flin Flon and all those places. So that's good.
Yeah, the weather forecast is for a warmer and drier than normal summer here in Nova Scotia. And I got to tell you, we're all waiting for it.
Yeah, well, you got air conditioning. That's probably why you're waiting for it. Yeah. Oh, well, burning Saudi Arabian oil to fund your air conditioning. Don't get me started. Okay. Let's see. We started this year with the, he's being quiet now. I just want to start a big sidetrack.
I know there's a rabbit hole there somewhere.
Yeah, don't fall into it. We started this year with these FDNY tips, and that's something you can download online. They do a PDF, and we pick one every week just to talk about, or every time we do. We don't do a podcast every week. Try to do two a month if we can. It's tough this time of year. Anyway, this week's is tip number 17 of 2023. They call it the well hole, which I didn't know what they talked about actually, but they're talking about the hole in the stairwell. If you have spiral staircases or square staircases that go around a center hole, basically they say well holes differ in size. If you can fit your gloved hand inside a well hole, it should be large enough for a well hole stretch. The presence of a stairwell hole in the stairway makes it possible to execute a well hole stretch as an alternative to traditional stairway stretch of hose. This type of stretch will use significantly less hose, take less time, and will be physically less demanding while still protecting the primary egress of the building. In order for the well hole to be used, it must be large enough to accommodate the hose. An effective test for size is a closed hand. If you can fit your gloved hand inside the well hole, it should be large enough to execute a well hole stretch. The presence of a well hole does not require the execution of a well hole stretch. The decision to use the well hole is made by the engine officer and should be clearly communicated to the members executing the stretch up the stairs. Before the decision is made to use the well hole, be sure the path of the well hole itself is clear. This is accomplished by looking up from the bottom of the well. Obstructions in the well hole, such as metal bars, can complicate the stretch. Also, be sure the well hole continues above the first floor, as variations in layout may impact the well hole. Conversely, be mindful that variations in layout may create a well hole that begins on the second floor. If desired, the well hole stretch can begin from that point. You should also determine the point at which the hose will be pulled out of the well and flaked out for fire attack. This point should be in a safe area as close to the fire apartment as practical. Most commonly, this will be on the floor below the fire or half a landing and stretched to the fire apartment by way of the stairs. In larger buildings, it may be possible to pull the hose out of the well hole and secure it on the fire floor if the stairs are significantly remote from the fire apartment to allow for members to flake out the required lengths of hose and secure it. Before the hose is secured, the engine officer must confirm that enough hose is available on the fire floor to reach the fire area. consider documenting the presence of holes in your pre-plans. So the most famous well hole stretch of all that I know of course, is the Meridian Plaza building, One Meridian Plaza building in Philadelphia, right? Yes, it was, where they stretched three large diameter hoses up about 27 floors because the standpipe system wasn't working because there was pressure reducing valves in the standpipes that were negating enough pressure and flow for their hose lines. So they actually took hundreds of firefighters and stretched large diameter hoses up 23 floors. And that's sort of the most famous one I know of. You, Denny?
Yeah, well, I was going to say, I'm glad that you mentioned the why, because the why is important. A lot of people would be going, why are you stretching hose upstairs? I mean, it's a supply line, right? So why are you doing that? Just use the standpipe. But the answer is exactly like you just said, Paul, because there were problems with the building system. Problems I would say in advance without knowing all the details on the One Meridian as to why, but why weren't those problems addressed before the fire? So, know your district, get out there, do testing. But one thing I did discover when I was doing in my last job is we were out doing some testing on some of our higher rises, and then we're not terribly tall, like 11 stories, that kind of a thing. But we wanted to see what type of flows we could get out. We'd redesigned our standpipe packs and nozzle system on the basis of some of the lessons learned from Meridian, but basically to be able to flow large amounts of water at lower pressures. And we wanted to see how that worked. And we went up to the top floor, hooked to the standpipe. And the reason we did that is because we were going to take the line out and flow it on the roof, right? Because, it was an occupied building. They rather looked dimly on water going down the stairs.
Down the hallway.
Right. So we discovered that part of the annual systems tests and so forth and inspections on those buildings did not include standpipe systems, and they weren't part of the code at that time. And so therefore we found problems, like we couldn't get the valves open. That was kind of an important problem.
Frozen shut.
So, well, yeah, and we tried the usual method of putting a pipe wrench or whatever on the handle, promptly broke the handles
Break the
off
handle
the
off.
valves.
Yep, exactly.
Right. Because, I worked in a refinery for 17 years, or heavy industry. So I know there's all kinds of tools available for turning valves that don't want to be turned. Anyway, we had them after that little incident because I designed a bunch. We had them built and we put them in our kits, our high-rise kits or standpipe kits, I should say. But the reason that you want to have an alternative to this building systems is because building systems are not necessarily reliable, particularly if you're not checking them on a regular basis. And by checking them, I don't mean some guy with a van and a certificate did the checking. You yourself did the checking, because his understanding, or that person's understanding of what is adequate for firefighting, is, I'll tell you, the perspective is different than your perspective as a firefighter. So get out. I'm going to say it again. Know your district.
Yeah, good point. The other famous one, Doug will shoot me if I don't mention it, is of course the Deutsche Bank fire in New York City as a result of of 9/11, and then the building was under demolition and the standpipes were disconnected and they had no water, and I think two or three firefighters perished in that one. We covered that episode, but again, they had to stretch lines up, multiple floors. So this is a relevant subject. Okay.
Yeah, and the other side of that pancake is buildings under demolition, buildings
Right.
under construction.
Yes, I know.
Where systems are not fully implemented. They're not working. A lot of towns and cities are bringing in bylaws whereby you have to commission portions of the standpipe systems, or whatever the case may be, particularly standpipes. Even as you go, you can't. You got to be up to within a couple floors of the top or whatever, because you've got a lot of fire load. You got scaffolding. You got all other kinds of issues. And in one town where I was a volunteer, many years ago, we had a fire in a truss shop. They had the largest truss building factory in Nova Scotia, and probably the largest east of Montreal. And they built a building supply building, 2-story at the front, and they were just stocking it, ready to open it, but they had not commissioned the fire protection system. So the sprinkler system in the building had not been commissioned. And they parked a forklift truck in the basement. Forklift truck caught fire, and the place was tilt-up concrete construction, and man, did it burn. And we
Oh, wow.
almost lost 2 firefighters when there was a backdraft. when they opened the front doors to go in. There were no windows. You see, you couldn't tell
Oh
what was
yeah,
going on
you couldn't
inside.
tell.
No, so they opened the front doors. Actually, they couldn't. They went in through the front doors. Air went in, backdrafted, and it threw them out the door. In fact, it threw them out the door so hard that, in fact, the doors were bent. The aluminum
Wow,
doors. There was that
wow.
much force. And again, systems were not working properly at all. In fact,
Well,
so yeah,
speaking, yeah,
Plan B,
exactly.
Plan C.
Yeah, so good points. So anyway, an alternative to stretching a hose line, up the stairwell through the middle. That's definitely a good way to go.
Don't use
Let's
your
see.
aerial.
Don't. Well, I used to sell aerials, right? Oh well, there's a connection on the aerial. Great. And I say that's fine. You can do that. In my personal belief, there is use the aerial to take the hose up to where you want it, but put the hose beside the aerial and let it hang off the window, balcony, stairway, whatever the heck it is. Don't tie the aerial to the building because you might want to move it. And if the hose line's tied to it, guess what? You're not going to move it. Hydraulics are strong, but it's not going to pull that hose off. So
Yeah. So,
anyway,
so, 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 so as a fire chief, speaking as a fire chief, you spend years talking to your local council about the need to spend what would it be now, Paul, two and a half, $3 million
pushing
on an
three.
on
Yeah,
a on an aerial truck because you absolutely need to have that aerial truck. Blah blah blah, and you use it as a standpipe to haul up 2 lengths of hose, which altogether might cost $1,000. And that's the purpose of your aerial truck. If I was a city councilor and I saw that, I would be having issues with it. You as a fire chief should be having issues with it.
exactly. Don't tie your aerial to the building. Use it to take the hose up and then let it hang. That's what hose straps are
Buy
for.
buy a rope.
Buy a rope.
They're
Yeah.
they're cheaper.
Okay, a couple current events, and then we'll jump right into this episode. So the only couple that I thought of here quickly this afternoon was there was another tunnel fire in France, I guess, yesterday.
Big
Something to
one.
watch out for. We're getting more and more tunnel fires. There was a one in Colorado a few months ago that shut the highway down forever. I think one person died maybe in it. The one in France yesterday, no one died. They fortunately got everybody out and they got the fire out quickly. The last large tunnel fire in France was the Mont Blanc tunnel that
Mont
burned,
Blanc.
and it was Mont Blanc, and it was closed for like 3 or 4 years after to rebuild it. And the one in Colorado is still closed. Seattle had a tunnel fire recently as well. They had a motorhome, I believe, in a tunnel fire. So something to watch out for. You don't get them every day, but if you do have a tunnel, you need to pre-plan it. You need to know what you're going to do and have the right equipment. And then, of course, surprise, a maritime theme here, another roll-on, roll-off ship fire. There's a ship stranded in the middle of the Pacific Ocean, south of Alaska, that was transporting 3,000 vehicles, some internal combustion, some electric, from China to Mexico. It caught fire on the way. I learned that that actually these ships have fire suppression systems on them. They have a flooding CO2 system in the cargo hold. So they tried to fight the fire. They used the flooding cargo CO2 system, just like they did on the ferry that burned in New Jersey. That killed 2 firefighters. We haven't done that episode yet. That'll be coming up. But apparently that didn't stop it. And the authorities for shipping on the ocean for ro-ro ferries and ro-ro ships have now changed the standard. I think it's SOLAS or whatever it's called. And they've changed the standard that now the top decks of these ships actually have to have fire suppression outside as well. So they, to try to prevent that because they're really having trouble. This is a third ship in as many years, for sure, maybe less, that has caught fire with vehicles on it. The one sank. The one went back to, they recovered it and it went back to the harbor and they salvaged it. And another one caught fire in Zeebrugge Harbor and they suppressed the fire with the suppression system. And then this one here that's currently burning. And there's a bulk carrier fire too, was somewhere off the coast of India, hazmat, and the crew all had to evacuate, and it's still burning. So, we're getting a lot of fires. It's still out there. We're not going to be out of work soon.
Low incident, high challenge fires.
Right. Yeah, exactly. How do you do those, right? That's the problem.
No, I was going to say the one that's south of Alaska. It's not really south of Alaska. It's south of the Aleutians, and they're like days. They were days away from being able to send the proper firefighting and ocean support tugs to grab a hold of
Yeah,
it. Like
I think it took
they were
5
like
or 6 days for the first
yeah,
tug to get there, and yesterday they were still waiting for another one.
yeah, like
Yeah.
Oceans are big, man.
Yeah, they're big and it's far away. And like, what are you going to do? I saw some of the pictures of the other one that burned, and the plating, all the plating on the outside of the ship was gone. It was like open, like a parking garage. Which there was another two more parking garage fires recently, and a collapse.
There
Where was
was.
the collapse? 2 days ago, there was a parking garage collapsed recently in the States somewhere.
Yeah.
Anyway, on with
Yeah.
this episode. So this episode is about it's kind of unique, and that's why I picked it. Even though it's 1999, so it's a little beyond our 25-year window, I picked it anyway because it's very relevant today, and it's not something you get very often. So I wanted to make us aware of this problem. So on June 11th of 1999, a call came into Central Dispatch at 1300 hours reporting smoke coming from an electrical closet on the second floor of a large department store. This is in Northbrook, Illinois. We'll get into that in a minute. Stating that they had smoke in the electrical room on the second floor, the lights in the store were out, the emergency lighting generator had failed to start automatically. The fire department dispatched 2 engines, a ladder truck, an ambulance, and a battalion chief. The chief of the department also responded to assess the situation. I guess because it was a big retail client and a significant, kind of event that might be special. So the chief went to the call as well. After receiving reports from the first arriving engine company that there was no fire in the store, the fire companies that responded were released to turn to the station. The chief requested that someone from the Fire Prevention Bureau respond. The assistant chief from Fire Prevention responded, and the chief briefed him as to the current conditions and situation. The lights were not operable in the store, no fire was found. An electrician had been called by the store's chief engineer to check out the electrical problem, and the customers had been evacuated. Now, a little bit about the community and the department. Go ahead, Denis.
Well, Northbrook, Illinois, it's a suburb of Chicago. For those who don't know, I didn't know, but now I know, and sits on the northern edge of Cook County. So it's about 20 miles northwest to the Chicago Loop downtown area. So you can picture Chicago sitting on the lakeshore. It's slightly northwest. The Northbrook Fire Department, protects about 33,000 residents in the village of Northbrook itself, and has a further approximately 4,000 residents who live in the rural districts surrounding the village itself. And the entire response area is about 16.5 square miles, so not a hugely large area, but actually a pretty substantial fire department for all that. The combination department employs 90 persons, 59 of which are full-time uniformed firefighters. Northbrook maintains 3 fire stations. They would normally staff 2 engine companies and 1 truck company. And there are also 3 paramedic rescue ambulances that they operate. And there is a district chief on a daily basis, so he'd be the shift commander, I guess. The fire department provides all new firefighters with training to level 1 and level 2, which of course refers to NFPA 1001 professional firefighting standards. So.
Just a point of trivia here. Northbrook, Illinois, I think that is where Federal Signal, which makes the sirens and the lights and everything else, is located. Corporate offices, I never got to them. I used to work for E1, which was a subsidiary of Federal Signal and Superior Fire Trucks, and they owned Vactor and Elgin Street Sweepers and several fire truck companies and stuff. And then they sold E1 off back in the mid 2000s or something like that, 2010. But anyway, just a trivia thing. So if you think of your Q siren, which all of us firefighters love, or the light bars and stuff, that's where it comes from, Northbrook, Illinois. The electrician arrived, and along with the assistant chief, the assistant building engineer, and the loss prevention manager for the store, they went to the engineering room on the first floor, which houses several electrical panels. The electrician started troubleshooting the emergency power system. First, he concentrated on the control panel for the automatic load transfer switch. So that would be the switch that would transfer over when mains power quits, would automatically transfer over to the generated power. You have one in your house, right, Denis? Automatic transfer switch? It ran for 26 days during the Tantalon fire?
Not quite that long, 13 days. That cost me $2,500 in propane.
But your food and your freezers and everything were okay.
That was my explanation to the insurance company. It says, you can pay me for the propane or reimburse me to throw out my fridge, my freezer, and everything in it. Your choice.
Did they
we'll
buy
take
that?
the propane thing.
They
did.
Yeah.
They says,
oh, yeah.
They says, oh, yeah, the propane's far cheaper. Thank you. Hell, I got a $3,000 fridge alone.
Yeah,
let alone the contents. Anyway,
Excellent.
we digress. Rabbit,
digress.
squirrel.
So, the load transfer switch, which is supposed to automatically start the emergency generator and transfer the emergency lighting circuit from the utility to the emergency generator for the duration of the utility outage. By the way, every fire station should have an emergency generator and an automatic load transfer switch and smoke and fire and freeze detection. It's just my little soapbox here. I see fire stations burning and no one knows it's burning until someone calls it in.
After the electrician tested the transfer panel, he then moved on to the emergency breaker compartment. So basically the distribution panel, right? The one that's full of the breakers. So you got, power coming in and being distributed out to the different circuits. So that's what they're referring to there. So he then moved on to the emergency breaker compartment. Which was powered by 480 volts. So 480 volts coming in and capacity of 200 amps. But that would be 200 amps across the main breakers. So it's basically line power on the one side and goes through the 200 amp breaker. So 480 volts, that's important. And that's where the utility power entered the store and then fed the emergency lighting circuit, as well as other circuits that were considered emergency use. So the electrician removed the protective front panel. That's the panel on the front that keeps you getting at the electrical bits inside. And he noted that there was a melted screw head inside the compartment. Interesting. The compartment contained the emergency power breaker, which was fed from the main panel. He then apparently proceeded to test that particular breaker for voltage on the incoming line terminals, but for which that he used an inexpensive analog multimeter, like one you bought at a local hardware store.
Radio Shack. No, they don't have those anymore.
Yeah, I wasn't going to name any names, Paul. So he then apparently proceeded to test the breaker, this particular breaker, which is a 200 amp breaker, for voltage on the incoming terminals. So there'd be 3 terminals, right? You'd have an A, B, and a C, right? Using an inexpensive analog meter. That's if it's 3-phase. If it was 2-phase, you'd have a black or red and a white, which is your neutral, right? So I'm not sure if it's 3-phase. Usually 480 volts is 3-phase. But anyway, he then apparently proceeded to test the breaker for voltage at the incoming line terminals using this inexpensive analog multimeter that he had borrowed from the department store maintenance department. So this electrician came to the store for an electrical issue and didn't bring a multimeter with him. So that's interesting. The electrician apparently verified power on all the 3 terminals, the A, the B, and the C. So it sounds like 3-phase. And this finding of having power on all 3 terminals seemed contrary to his expectations. He then tested the A terminal again, and then he tested the B terminal again, at which point he said, that's not right. And then he tested the C terminal again. He then proceeded to repeat the measurements in reverse order, and that's when things went wrong.
At approximately 13:45 hours, he was placing the meter probe on the center terminal B when a fault occurred, resulting in the formation of a fireball. The fault persisted for a few milliseconds, during which time it vaporized the bus bar. We'll put some pictures in here for you later on the social media, and the steel mounting structure in the vicinity. The fault burned itself out because it consumed the line side bus bars. The assistant chief was standing alongside to the left of the electrician when the fault occurred, and the assistant building engineer was behind the electrician observing his activity. Both the electrician and the assistant chief were critically injured within seconds by the intense heat, estimated to be in excess of 3,000 degrees Fahrenheit, produced by the electrical discharge fireball. The assistant building engineer was severely burned along his left side. All 3 were transported to local hospitals. The electrician received 3rd-degree burns over 98% of his body and died the following day. The assistant chief received 3rd-degree burns over 93% of his body and died 10 days later. The cause of death for both victims was listed as thermal burns.
So what happened there is when he tested it with the meter, he caused a circuit going through the meter and through himself. And so that's what happened as the electricity ran through him. So that's why he was burned over 98% of his body. It was like being struck by lightning, basically.
Right. Commonly known as an arc flash. That's what this is called. If you search YouTube and look up arc flash, this is exactly. You get too close to energized equipment and potentially provide a pathway, a circuit to ground, you are the one getting shocked.
You become the wire.
You're the wire.
And if you're not actually, if that's not actually the mechanism that gets you, you can have an arc, short circuit that occurs very close to you, and you get this large flash of basically plasma, like the surface of the sun, that just is a big enough volume that you're on the inside of the volume, and that could be fatal also. So it's hard to know exactly what happened here, but most likely it was the multimeter that caused the circuit to short. Started it, not
yeah. We picked this
started the
episode
short.
because it's not something we commonly worry about. We're firefighters. We're immune to everything. We see electrical panels. Sure, we go in there, and start poking around or whatever. And we need to be aware of arc flashes because they occur routinely. There's no stats on actual just arc flashes. There's stats on electrocutions, and it's like 150 a year or something in the one stat we looked at. But anyway, these do happen, and so we want firefighters to be aware of this. If you go monkeying around in electrical rooms, electrical panels, you want to be trained and you want to have the proper protective equipment, which in this case they didn't.
So just a couple of comments on that, Paul. You said at the beginning that this is an unusual incident. Electricians being killed or severely injured through arc flashes is not that uncommon.
Right.
I know of a couple others. Just in the back of my memory, I can remember two others right off the one in particular. But the main thing that's unusual about this one is that it involved a member of the fire department. And just to bring this into more focus that I know every firefighter would certainly appreciate is, would you put a hose line on an electrical charged panel, a charged electrical panel? Would you do that? And you're basically taught, don't do that.
Right. Especially not straight stream.
Yeah. So that's any fog. That's any fog nozzle. It doesn't matter what pattern the stream is in. So you wouldn't do that. So that's, if you wouldn't do that with a nozzle flowing water, you certainly wouldn't want to do it with a multimeter if you didn't really know what you were doing. And in this case, the mistake made by the assistant chief was standing next to the person who made the error. So there's a number of recommendations that came out of this incident. So this is, again, after the fact recommendations. So recommendation number 1. Employers, in this case the fire department, should develop and should implement a hazardous energy control program, which includes procedures to de-energize, to lock out, and then to tag out any electrical component system that has a fault or potential fault prior to initiating any work. So what they're saying here is don't depend on the elevator technician, the electrician, anybody else to make your workplace safe. Essentially, that's what they're saying. You need to have your own process in place. And, we put lock boxes on our trucks for that reason, with means for locking out valves, locking out breakers, whatever. Employers should develop, should implement, and should enforce a hazardous energy control program for all workers who perform installation, maintenance, service, or repair work, and we would fall within the service category, near any hazardous energy sources. So this was 480 volts. I know a lot of guys out there listening to this will go, yeah, so what?
I kind of didn't think much of that voltage either.
Apparently that's enough. I know you can get killed with 220 volts.
Yeah.
So even 110, if it goes through you, you're standing in water, which is why you don't see electrical outlets close to the bathtub, because that can happen. Anyway, the hazardous energy control program that you should have should also include procedures for de-energizing, locking, and tagging all of those energy sources that appear to be problematic. And that's the point. You need to be aware, and that could create a hazard to employees, and verifying thereafter. So you lock it out, make sure you locked out the right thing, and verifying that de-energization has occurred prior to initiating any work. So before you open the door on the cabinet, before you stick your nose in there and start jabbing at the terminals, you really want to be doing that. So testing of energy isolation points, such as at breaker panels, can expose workers to the inadvertent release of hazardous energy and should be included in any hazardous energy control program. Remember, they were there because something wasn't working properly. That's pretty much a red flag also. Normally, these panels are made safe to be near flick breakers and stuff. But in this case, something was wrong. We know that because the power wasn't flowing. and you were exposed to it as soon as he took the panel cover off, you are now directly exposed to the hazardous energy.
So, employers should train their workers in the basic concepts of hazardous energy control. Basically saying that the basic concepts, including proper procedures for de-energizing, locking and tagging energy control devices, and verifying de-energization prior to initiating any work. Workers whose duties involved installation, maintenance, service, repair work should be trained in the detailed control procedures required for their work situations. And I'm going to try to include in our socials a link to an NFPA worksheet about electrical safety.
Yeah, but think about a kind of a parallel episode, if you will, or incident that could kill a firefighter, where we're part of the basic procedures that we learn pretty much from the get-go is how to make that equipment safe, and that would be an elevator rescue
Yep.
intervention in a stuck elevator. What do? You go and you force the doors open, you stick a ladder down there, you get the person out of the elevator. No, that's not the first thing you do. What's the first thing you do? You go to the elevator control panel, you lock it out, and if the control cab and whatever is the control room, the mechanical room is up on a penthouse, you send a guy up there and he locks it out and de-energizes it. And some departments will go further and take additional steps. So you want to be, before you do anything, you might talk to the person through the door and say, don't panic, we're here, we're going to fix it for you. But you make sure the elevator is absolutely not going to move while you're working on it. That
Same
didn't
reason
happen
you
in this
chock the
case.
wheels on the fire truck. Yes, the park brake is there. The wheel chocks are that extra step to make sure it doesn't move.
Yeah. And normally you learn that by not doing it the one time when it matters.
Right.
But, your department needs processes and procedures, obviously. Recommendation 3, employers should ensure that employees wear the appropriate personnel protective equipment when working on energized parts, including voltage testing. Okay, who's the employee that was working on the voltage testing? Well, it was the electrician, but who was standing near enough to be within the danger zone? That was the assistant chief, unfortunately. He was obviously unaware of the risk that he was at. So, according to the National Electrical Code, employees working in areas where there are electrical hazards shall be provided with and shall use protective equipment that is designed and constructed for the specific part of the body to be protected. You're working on a medical call, you wear breathing protection, you wear a gown, you wear gloves, whatever you need to do, right? Same thing with electrical work. And so you say, well, the assistant chief wasn't working on the thing. Well, actually, he was. He was closely observing. We're not sure why, but he was. So it's equivalent to working. In this case, working on energized parts, including voltage testing of the emergency breaker compartment, required the worker to wear appropriate eye and face protection and head protection, gloves, and footwear, and possibly permanently isolating other methods such as standing on an isolated floor mattress. That might have saved the electrician.
Because they wouldn't have been a path to ground.
Right. But the
Yep.
guy standing next to him, the assistant chief,
Would have
would
been.
not have had all of
Yep.
that, and he would have still been likely hurt,
Injured.
killed
Yep.
in this case.
Recommendation number 4, a flash hazard analysis should be done before being exposed to an energized conductor or a part that has not been placed in an electrically safe condition to determine the proper flash protection boundary. The electrical system in this incident is a fixed emergency breaker compartment with 480 volts, 200 amps. If the live components are not placed electrically safe work condition, other safety-related work practices such as PPE should be used to protect employees who might be exposed to the electrical and or burn hazards involved. Additionally, unqualified persons should maintain a distance from the exposed energized conductors, including the largest conductive object being handled, so that they cannot contact or enter into a specified area. The safe approach distance is the limited approach boundary to guard against the shock hazard from energized conductors and circuit components. To guard against electrical arc burns, persons must not cross the flash protection boundary without appropriate PPE and must be under supervision of a qualified person. Unqualified persons should be advised that the designated person in charge of the workspace with the electrical safety hazard to stay outside of the limited approach boundary. In certain circumstances, flash protection boundary might be greater than the limited approach boundary. in which the greater distance should be utilized. As stated by NFPA, flash protection boundary for systems which are 600 volts and below, because when I read that 480 volts, I go, oh, that's not a big deal. 200 amps. My house is 100 amps. But this is in that category. Less than 600 volts should be a minimum of 4 feet. You need a minimum of 4 feet to be protected from getting potentially grounded out.
So what we don't know is why the assistant chief was standing so close, and maybe he's a guy who knew something about electricity and was
Maybe.
interested in knowing what the mechanism of failure had been at this point. And I'm as guilty as that as anybody, because I always felt that I knew more about electricity and how electricians worked and so forth than your average firefighter. And so I was always quite interested in problems and issues and how that had happened. But you have to in this case, and I would force myself to do that, to stand back and realize that that's not your job. You don't need to be there. All you need to know is that you're going to order an electrical inspection on the building, because really that's what you're going to do. There's a problem, you're going to issue an order to fix it. That's your job. so
Yep,
so
exactly.
you don't need to be close to do that. In fact, you don't even need to be at the building to do that. But in this case, he was closely watching what was going on, probably not as part of his job, but probably as part of his circle of interest. And sadly, it was a fatal mistake in this case.
So Denis found an article from NFPA talking about arc flash and stuff like that. And we've got an excerpt of this article here, is what is an arc flash, that we thought was relevant directly to the podcast. An arc flash is a result of a phenomenon known as electrical arcing. In very simple terms, an electrical arc forms when electrical current is sustained outside of its normal conductive pathway, such as in the air. Although air is normally non-conductive, air that has become ionized, meaning its particles have gained and lost electrons, creates a conductive gas-like material known as plasma, through which electrical current can flow. Electric arcs usually form as the result of a number of factors, such as high voltages or currents, moisture content, or damaged or degraded insulation. I mean, when you watch an electric motor working, that's an arc, isn't it?
Well, brush types, yes, but nowadays most motors are brushless. They're
Right.
induction motors, right?
Yeah.
So, but I'm going to speculate here, and I think what happened, and they don't say this here, is that the electrician was holding the meter in his hands, probably close to his body, and he was testing. So the one wire would have been on the ground, like the panel itself, grounded to the panel, and the other probe, which is usually the red probe, he was testing the various terminals: the A terminal, the B terminal, the C terminal, and these actually would have unlimited voltage because they're attached to the mains, so they go to the main circuit on the street. So not truly unlimited, but much more than 200 amps. And what probably happened was the small wire on this voltmeter was not rated for the voltage that was exposed to, so the insulation was inadequate. So what happened is there was an overcurrent probably that went down this wire, and it was outside the wire. Actually, the wire was just the path, and the voltage was probably formed a cone outside of the wire, traveled down to the multimeter and electrified him, which then electrified the guy next to him. Something like that happened. And once that starts to happen outside, then the air becomes part of the conductive path. It ionizes. So this would happen so fast, you'd have no time to even notice. I mean, there would be a massive flash. Anybody who was watching this would have seen this electric welding type arc flash, and there would have been quite a bang too at the same time, because it travels at the speed of light very, very quickly, right? And so there would have been this massive flash bang, and these two guys would have dropped. So you don't have time to go, oh, let's not touch that. Too late. It's done.
So the article goes on to say the size of an electric arc can vary widely. Many studies over the past decade, scientists have observed arcing across gaps between electrodes that are mere nanometers in length. On the other extreme, lightning can be considered as an example of electric arc that spans miles in length. In recent years, some scientists have begun classifying lightning as sparks rather than arcs due to their short-lived nature. While electric arc, arc flash, and arc blast are all sometimes used interchangeably, there are some minor differences in terminology. Arc flash describes the intense light and heat generated during electrical arcing, while the term arc blast can be used separately to refer to the pressure wave created from the electric arc.
Yeah. So fundamentally, it comes down to this: working around energized electrical equipment, and firefighters know this, can pose extreme hazards to firefighting personnel. We stay away from downed wires. We don't spray hoses into electrical
Electrical
panels,
panels.
electrical wires, transformers up a pole. We don't spray water on those things. We have a huge amount of respect for all of those obvious sources of electricity. You need to think about it comes right into the building as well. So working around energized electrical equipment, of course, can pose an extreme hazard. The electrical service panels in a large commercial and or institutional building pose a particular hazard. They're not your home panel because of the increased voltages and amperages of the equipment typically found in those occupancies. Often there's transformers there too, right? Personnel should institute procedures to isolate all power sources, including emergency backup power. That's important. And ensure the electrical equipment has been properly de-energized before any protective areas, uh, access panels are removed. So if you isolate the mains and there's a generator there, you got to isolate the generator, which means shut off the fuel source for the generator, shut off the breakers at the generator, because if that starts, it could start within a minute or two of you isolating. Shut off the main breaker. Okay, it's all safe now, and then the generator starts. It's not safe. So you need to be thinking about in 360. You got to do your 360 on your electrical system.
Well, and also the batteries, right? We're starting to see the energy storage devices in homes, these, Tesla power walls and stuff like that. They may
And
have,
solar.
and solar, which is generating power and maybe going to, well, the whole house, and solar's always energized. Unless you cover it up, it's energized. Even the floodlights on the fire trucks can give that enough light to create energy. And then, of course, if it's going to and there is usually an isolation switch. I think that's in the standards now. I don't know, that isolates the house from the solar, but the switch from the solar is always energized. There's been a whole bunch of fires in Europe with solar panels on roofs. As they increase the number of solar, they're having more fires because, problems, right? You're going to put this in your most exposed area of the building. It's going to be, be subject to weather and everything like that. So anyway, watch out for the auxiliary generators you don't think of. It may not be internal combustion engine powered. It may be a storage device of some sort.
Yeah. So really what Paul is saying is this isolating electrical is now becoming a multifaceted aspect. And like you said, covering up solar, well, it's not a tarp off the truck. It has to be the proper tarp for isolating solar. It, it can't let any light through. So you need to have a process all for that, all by itself. So anyway, all work performed on electrical equipment should be done by qualified electricians. Qualified is an important term here. In this instance, the electrician appeared to lack the proper knowledge and training to service high voltage equipment. Unfortunately, the fire officer killed in this incident apparently was lulled into a false sense of security and should not have been in close proximity to the open service panel while the electrician was testing the system. So if you're a fire officer and an electrician's coming in to work on something, don't get all shy. Ask the questions. What's your qualifications to work on this system? Are you familiar with the system? Have you ever worked on it before? Have you worked on high voltage systems before? And if he says no to any of those questions, I'm sorry, we're not going to permit you to work on this system. You got to do that, man. Protecting your own guys.
Yeah, we need to, honor the service of Assistant Chief Wayne Luch, I may mispronounce that, today by reviewing your lockout tagout procedures for dealing with energized electrical sources and touring an electrical service room in a large commercial occupancy with your crew members today. Thanks to multiple media sources for additional information for this article, and remember the fallen brothers. Get out there and know your local. And this information comes from Rick DeGroot's Building Construction for the Fire Service and from the NIOSH report. Thank you all for listening to another episode of the Emergency Traffic Podcast. We appreciate that, and let's stay safe out there.
Yeah, thanks, Paul. A simple error led to a fatality. Man, it's heartbreaking. It really is. So take care every day. Hope you learned something from this particular episode. Thanks, everybody.